And let's go ahead and get started on section 5.3, which is talking about scientific notation. And scientific notation is probably called scientific notation because it deals with really, really, really big numbers and also really, really, really small numbers. Okay? Like science. You know, if you're talking about the distance from here to the sun, that's a really, really big number, right? Or the mass of the sun, really, really big number. So they use scientific notation. Or if you're talking about like the size of an atom, okay, diameter of an atom, or whatever, it'd be a really, really tiny number. So we have scientific notation, and here is how we deal with scientific notation. It's really, really big numbers or really, really small numbers. For example, the distance that light travels in a year, the mass of a single hydrogen atom. So really big or really small numbers. Okay. Because what happens is you end up having so many zeros because it's such a big number or a really tiny number, a decimal point, and then a bunch of zeros, that it kind of loses meaning for us. But our standard form for scientific notation is going to look like this. We're going to have some number, and then it's always times 10, and then it'll be raised to some power. So the only thing that's going to change here is the number in the front. We'll have to figure that out. And then the exponent number here on the 10. But the times 10 will always be there. Okay? And then our number in the front, this A value, is always between 1 and 10. So your decimal point will always go behind the first non-zero digit. So we're going to do some examples like that so we can see that. The first one we've got is to convert 14,200 to scientific notation. Now this one is not too big, so you probably wouldn't use scientific notation, but this is just for practice. So here's what happens. Our decimal point always goes behind that first non-zero digit. Okay, it goes to the right of the first non-zero digit. So we're going to write 1.42, and we just write down the numbers until we hit the rest of them being zeros, and then we stop. So 1.42. Well, I think it's page turn, but we're fine here. There's your So we write down our 1.42, and then what we do is, oh, and I should mention one other thing. We have to know where the decimal point is to begin, and then we're going to put the decimal point right here. So you guys know where the decimal point is in just this number normally, 14,200? Do you know where the decimal point is, even though it's not written?
Between the zeros?
It's actually at the very end. If there's no decimal point written, it's automatically at the very end. Okay, so when you say 15, the decimal point is after the 5. Or when you say 326, the decimal point is after the 6. Okay, we just don't usually write it unless we have to. So this is where the decimal point is, and so we're going to write 1.42, that's the A, times 10, which will always be there, and then we just count how far. 1, 2, 3, 4 digits, we're moving it, and so we're going to put a 4 here, and then the last question we have to ask ourselves is, should it be a positive 4 or should it be a negative 4?
Negative.
Okay, well, here's how we figure that out. Here's how we figure it out. You guys are both very confident. Here's how we figure it out. If this is a big number, bigger than 1, it's going to be a positive exponent. If it's a small number, smaller than 1, it's going to be a negative exponent, because think about what's happening. 10 to the fourth power means 10 times 10 times 10 times 10, right? If you multiply by 10 a whole bunch of times, what happens? It gets really big, right? What would it mean if we had 10 to a negative 4 power? What did that negative exponent mean?
Does it become positive?
It becomes 1 over 10 to the 4th, right? That's what the negative exponent means. Reciprocal.
Mm-hmm.
So it really means you're dividing by 10, dividing by 10, dividing by 10, dividing by 10. So that's why the really, really tiny numbers are going to have negative exponents. The really, really big numbers, positive exponents. So you don't have to necessarily worry about this. Just think big numbers, positive exponents, small numbers, negative exponents. Okay, so, and we're going to be practicing these, so.
Okay, can you explain that again?
Which part?
What number, it's positive because it's,
The 4.
But what number is less than? Why is it positive again?
It's positive because this is the 14,200, the original number, is a big number, bigger than 1.
oh,
Or bigger than 10, we'll say.
and if it wasn't,
If it was a small number, like a decimal number smaller than 1, then you'd have a negative exponent.
just like,
Okay? So if you just remember big numbers, positive exponent, and then you'll see some small numbers will be negative exponents. Okay? So let's go on to the next one.
So we don't have to write 1 and then,
So your answer was 1.42 times 10 to the 4th power.
and that's the answer.
That's it.
Okay.
So this one, where do you think our decimal point should go when we start to write this in scientific notation?
Between the 4 and the 2.
Between the 4 and the 2, because 4 is your first non-zero digit, right?
Mhm.
So we're going to write 4.2 times 10. Okay, once you figure out this is your A, 4.2, and then you always put times 10, and then we can see our decimal point right here, right?
Mhm.
And the question is, how far do we move it? Well, we move it 1, 2, 3 spaces.
Mhm.
But what can you tell me about this number? Is it
negative.
it's a small number, so that means it's going to be a -3. Okay. So you're always just, the two things you have to think about is, where does the decimal point go for your A? And then count, and then should this be a positive or a negative exponent? Those are the two things you're looking for. Any questions on that one before we go on? All right. So how about this one? Now this one, we're given scientific notation and we're supposed to write it in standard notation. So how you would normally see the number. So here's what I'm going to do. I'm going to write this here. And we're either going to move the decimal point, how far?
5.
5 spaces. And we have to figure out, do we move it that way or that way? Do we move it to the right or do we move it to the left? So what do we know about this? What sort of, it's positive. So what sort of number should we end up with?
Big number.
A big number, right? How do I make this into a big number? If I move the decimal point this way or move the decimal point this way? We're going to move it this way, right? So we're going to move it 5 spaces. So 1, 2, 3, 4, 5. This is where our decimal point will be. And all these little spots that are open, we just fill those with zeros. So 321,000. Okay.
Okay, wait.
Okay.
Oh, okay.
Sorry.
Okay.
All right. Any questions on that? Does that make sense? All right. Nobody's asking
I
questions.
don't know.
You think. Okay, wait. Okay, I got it. Wait, never mind. I'm not sure.
I don't know.
All right, let's try another one. How about this one? We're going to write down our 7.4. We know we're going to move it 3 spaces. But again, since this is a negative, what does that tell us about our number when we're done?
It should be a small number.
It's going to be a small number. So which way should I move the decimal point if I need it to be a small number? This way, right? So how far am I going to move it?
3.
3. 1, 2, 3. My decimal point will be here. I put in my zeros. So 0.0074 will be our answer in standard form, standard notation.
Okay, so back on the 321,000.
Yep.
How'd you know to put the comma between the zeros?
Oh,
Because
it's
you
just-
because
okay.
of common sense.
So we had, so if we had 321,000 and the decimal point was here,
Mhm.
it's always after your first 3 numbers. After every group of 3, you put a comma. If you didn't write the comma, it doesn't matter. But the
Oh.
reason that we do it is because if we actually read this number, it's 321,000,
Yeah.
and then whatever's after that. That
Okay.
tells us, or if
So
you had a
the
comma
common sense
here,
thing.
it means something 1,321,000.
Got it.
And so the comma is every time you give another label to
Yeah.
your answers.
Okay.
But yeah, that's why. After the decimal point, you don't put commas in. You just leave them. Okay. So does that make sense?
For up to the decimal, it could be 4 digits.
After the decimal, you could have 100 zeros. You don't put any commas in. Why? I don't know. In fact, I know in some countries they instead of decimal points they actually use commas to mean decimal point.
Do
So
I need to put the decimal?
for this one, yes, you have to put the decimal there so that you know that these numbers are after the decimal point. We have to know where the decimal point is. If we can't see it, we assume it's at the very end. Okay, like that 321,000. When we rewrote it, we didn't put the decimal point at the end after those zeros because it's understood to be there. Okay,
Can we see it on the video? Can you see it can you see yourself on the video? Or
I can see myself.
no glare?
This, well, the glare would be right here. So you can see most of it.
Okay.
All right, wait. I almost skipped past something. Okay, now when we have this, what is it telling us to do?
Whatever she says all the time. The word. Distribute?
Actually, no.
Oh.
But I know why, because you see parentheses and you think distribute, right? But here's the difference. What is this?
Times.
Like,
Times.
So
Times.
we're good at
You
writing.
only distribute if there's pluses and minuses in there.
Oh.
We're actually going to talk about that later tonight, but not right now. This is all multiplied. This really just means 2.1 and then times 10 to the -7th times 3.7 times 10 to the +5th. It's just all these things are multiplied together. Okay, so we write it this way, but again, this is what it really means. You're just multiplying all these things together. Because if you remember back to your properties way back when you multiply, the order that you multiply doesn't matter and the grouping doesn't matter. So these parentheses here really don't mean anything other than saying this is a scientific notation number and this is another scientific notation number and we're multiplying them together. That's all it does to kind of show you scientific notation, scientific notation. So here's what we do, and you're going to want to grab your calculators for this. What we need to do is multiply the two numbers, the 2.1 and the 3.7 together, because we're going to group these two together first.
Oh, really?
And what do we get when we multiply those together?
Wait, let me erase.
my calculator's down there somewhere.
Sorry,
7.77?
7.77? Is that what everybody's getting? Okay. So then I'm going to say it's right. I don't know. I'm trusting you guys to multiply this for me. And then we're going to put this in scientific notation. So we're going to write our times 10 because notice what we have left. These two, 10 to the -7th times 10 to the +5th. Now, what is our rule for multiplying things that have the same base? They both have a base of 10 and they have exponents. We add them, right? So it's
Yeah.
going to be a -7 plus a 5. And what does that give us?
Negative.
-2.
Okay.
So that is our answer when we multiply those two together.
That's it?
That's it.
And that's the answer you're
Give
looking
the test
for?
right now.
Well, we have 2 more lessons to go through tonight, so
Yeah, right. Kidding.
So
she's feeling confident after that last test. I'm sorry, what?
nothing. So this is all you're asking, like as far as
Yeah, you just simplify it. So multiply together and make it,
Nothing else to simplify.
rather than 2 numbers in scientific notation, we multiply them together and we get 1 number in
So
scientific
you would
notation.
use 7.77 times 10.
No.
No.
No. You multiply these two, group those together, and then your ones that have exponents, you group those two together. Okay? Make sense?
Yep.
All right.
it's totally wrong. Start doing it.
So you're doing it totally wrong?
Okay.
Well, it's a good thing we figured that out.
Yep.
Okay, now this one. So again, what this means, and I'll write it this way, but it means the same thing. It's 4.96 times 10 to the 4th, and then 3.1 times 10 to the -3rd. And I know you guys were doing problems like this with variables this week because Concha just asked me about some of them earlier tonight. Okay, so here's what we do. What do we want to do with something that looks like this?
Switch it.
Move it up.
Move it up to the top, right?
Mm-hmm.
So this becomes 4.96 over 3.1. And then we also have 10 to the fourth. And now we would also have 10 to the third, right? And I didn't make this line keep going. I mean, I could. But really, I want to focus on the fact that, again, we're going to deal with these numbers first.
So you always have to switch them if they're negatives. before
I like
everything.
to. You don't. I mean, you could just use your subtraction rule if you remember 4 minus
Oh,
negative
you
3.
can?
Yeah, you just have to subtract a negative, which makes it into a positive anyway.
So then you have
'Cause
to
you would
make
do-
sure that you move it up.
You would do 4 minus negative 3 using your rule. I just think it's easier to move it up and say, oh, 4 plus 3, 7.
Okay.
I mean, if you want to do it the other way, that's fine too. So go ahead and combine your numbers here. What do we get when this is saying to do what?
Divide.
Divide. So 4.96 divided by 3.1. What do we get there?
1.6, I think.
1.6. Exactly. Yeah. Okay. I got a yes. Times 10. And then what do we get when we combine these two tens?
7.
10 to the 7th power. I'm trying to avoid the glare if I can. So this right here is our answer written in scientific notation. So when you're doing these, deal with your numbers first, and then deal with the 10 part.
So you said it's, yeah, 1.6 times 10 is 7.
Mhm.
Do you want the X? Can it?
You mean this?
Oh, I guess they can't be together now because numbers, right? Because with the letters, you don't have the.
Right, you don't have to have space. With this, because they're both numbers, they, again, for scientific notation, they always put that time sign in between just to show this is the standard, and it's not up here anymore, but this is the standard form we use, A, some number, A, times 10 to whatever power. But again, like I've been showing you, it actually means the same thing as this with just like a dot in between, or you can put parentheses in between or something, but just standard form for scientific notation, they put that times 10. Okay, does that make sense? Are you okay with the calculator usage there? All right. Oh, this one. What's going on here? 1.8.
I like this one.
You don't like this one?
I like it.
You do like it. Okay.
Okay.
1.8 times 10 to the negative fourth. So let's write down what this means. 1.8 times, and then 10 to the negative fourth. And we're doing cube. Now, this is probably a time when we're going to break the rule that I was talking to you about earlier, like simplify inside the parentheses, because we actually want to leave this like this because it's scientific notation. We don't want to make it into a fraction. We want to have it not be a fraction. Okay, and this would make a fraction, right? This negative 4.
Mm-hmm.
So we want to leave it in scientific notation. But what happens here?
No, we do have to.
Yeah, the 1.8 gets cubed. The 3 applies to both of these. 1.8 gets cubed. And then actually the 10 to the negative fourth also gets cubed.
Make it.
So if somebody could grab their calculator and do 1.8.
It's at the bottom of the back. Somewhere.
The phone is going to have to do the work. We're going to have some decimal points here, but that's okay.
5.832.
5.832
Mm-hmm.
times 10. And then what will happen with our exponent here? What's the rule? Multiply. So negative 4 times 3 is going to give us negative 12.
I think there I would be like, okay, it's negative, you're going to the bottom.
Yeah, and you could, but again, you're going to turn it back into scientific notation anyway. So you're going to end up moving it back up to the top. But you're right. With our normal simplifying, unless it's scientific notation, you definitely move it to the bottom because we want to keep those exponents positive. Now, can somebody tell me, this is not part of the problem, but if I wanted you to put this into standard form, we would start with this, right?
Mm-hmm.
And we would have to move the decimal point 12 places.
Mm-hmm.
Which direction?
Left.
To the left to make it a really tiny number, right? You'd end up having 11 zeros and then this
Mm-hmm.
after the decimal point. So 0 point and then 11 zeros and then this. So that's why we do some of these things in scientific notation because you have so many zeros, you lose track of what that actually means. Okay. Any other questions on this one before we go on?
There's still more to it, right?
What?
To that answer.
No, this is it. Right here.
You're never gonna make us multiply.
We already did multiply. Oh, you mean multiply these two together? No, you always keep them separate.
And you're not gonna make it positive.
This?
Uh-huh.
You mean move it down to the bottom? No. When we're doing scientific notation, that times 10 just
Okay,
stays where it
I gotta
is.
remember that. Scientific notation.
It's special.
Don't move
It's
it
a
down.
special form. So you just
Leave
always
as
leave
a
it the same way.
simple notation.
And the
Okay.
directions will say something like, write this in scientific notation or simplify this scientific notation. So you are hopefully drawing your attention to the fact that this is scientific notation. Don't be moving things around. It should always be a number times 10 to a power. That's all.
That's scientific notation.
That's scientific notation. A number times 10 to a power. Okay. So let's try this one. This one is one that is a little bit different, but similar, but you're going to see what happens here in a second. So what did we say that we want to do? We want to multiply those two numbers together. So what are we going to get when we multiply those two numbers together?
$28.67.
Okay, everybody getting that? Times 10. And then what are we going to get when we deal with these two? 6, 10 to the 6th.
Okay, you said multiply, right?
Yeah, when we multiply these two, or which one are you talking about? The beginning?
Yeah,
You're multiplying everything, but we multiply these two first, and then we multiply these two, but because they have exponents, we add the exponents. So we get 6.
I started to add.
Okay, now here's the issue. We have an issue here that we have not had yet. This number right here is too big. Because this number right here is always supposed to be, if you look back at the very beginning, it's always supposed to be between 1 and 10.
Okay.
So it's too big. You see where the decimal point is and where it's supposed to be? Right? Does that make sense? It's supposed to be where? Between the 2 and the 8. That's where we need it. If we're going to write our answer in scientific notation, we need the decimal point to be right here. Does that make sense? Concha doesn't like that. She's giving me a face. Or she's just giving a face. Not necessarily to me, but she's like, I don't like that.
I don't like it, but yeah, you're right.
All right. So if the number is too big or if the number is too small, we need to adjust it a little bit. And usually it's not very far, but we need to adjust it a little bit. So let's just think about this part by itself. So forget this for a second. Just this part. If I was going to change just this to scientific notation, how would we write it? It would be 2.867. Whoops, that's not a 7. 2.867 times 10 to what power? How far do we move it?
6.
No, forget this for a second. Just this one.
1.
To the 1, and is it positive or negative 1? Is this a
-1.
big number or a small number? Is it bigger than 10 or smaller than 1?
Bigger.
It's bigger than 10, right? That was the issue. It's 28. So it's a positive 1. Okay, so that's this part in brackets or underneath that I underlined. Then we still have the times 10 to the 6th. So now what do we do with these two? 7. So this would end up being 2.867 times 10 to the 7. Now again, that's what I'm trying to do is show you probably the easiest way to simplify it. Once you start working with them and you're like, oh, this is too big. I am going to move it one place. I need to add 1 to the 6 because it's too big. Okay, but this is just using exactly what we did before and then combining like we did before. So that's why I say it's probably the easiest. It's not a shortcut. It's just exactly what we've done previously. But again, make sure that you remember if your number is bigger than 10, that means positive exponent. If your number is smaller than 1, it's going to mean a negative exponent. Okay. Looks like I've got some pondering going on.
So if the number is too small and we have to adjust it, you
you'll have a little negative exponent, so you'll end up subtracting. Yep. 1 or 2 or how many? It's usually 1. Usually we're either 1 spot too big or 1 spot too small.
Bigger than 10, you said?
Bigger than 10 or smaller than 1. Because we want it to be between 1 and 10, right? So if it's bigger than 10, it's too big. If it's smaller than 1, it's too small.
And that one is positive.
Bigger than 10 is positive. Smaller than 1 is negative exponent. Okay?
And you're talking about the,
I'm talking about this number right here is 28.67. So that means this exponent has to be positive. Okay, because we're just focused on just this part. If we were just looking at 28.67 and trying to change it to scientific notation, the decimal point needs to go here because 28 is too big. It needs to be smaller. So 28 is a big number.
so it always has to be smaller than 10.
To be in scientific notation, the decimal point always has to be behind this first number. Yep. And that's what that, if you go back to the beginning, that's where it says A is bigger than 1 and less than 10. That's what that means. It has to be in that range for it to be in correct scientific notation.
To be between 1 and 10.
Yep. You guys are such diligent note takers. I appreciate
And
that.
so there's,
Your heads aren't down like sleeping on the desk. Like,
Oh.
not that that ever happens in my classes, but you know. Okay, sorry.
okay, so then, if it's not, so I got you to show me I moved it.
Mhm.
So give me another number,
Okay.
so I can
That-
tell you where to put the period.
Oh, okay. So let's say we had, okay, so this is totally made up. This is not on your notes, but let's say that we had done something and we got 95.2 times 10 to the negative 8th power.
Then I would move it between 9 and 5.
It needs to go right here so that it's
It would be, 10 to
9.52
the 1.
times 10. This part would be 10 to the first. And then again, we would have the times 10 to the negative 8th. So we would, combine those two.
Got it,
Does that make sense?
I think.
And so we would get 9.52 times 10 to the negative
Yep, I
7.
was missing the rule, it has to be between 1 and 10.
Yep. And every one of the other examples, it was already between 1 and 10. So we didn't have to do anything. This was the first one, like I said, that it wasn't between 1 and 10. So we had to move it that time. Okay? Does that make sense? All right. Hopefully everybody was done writing that down. So how about this one? So again, remember we want to combine these numbers first, divide. So what do we get when we take 2.014 divided by 3.8? Hopefully it's relatively nice.
0.53.
0.53. Is that what everybody's getting? And did you have to round that off or did it just come out to 0.53?
It just
Came out, okay. Times 10. Now, I'm not moving this one. You can move it if you want. But what do you think, and we'll just take a shot at it first, what do you think is going to happen when we combine these? Or how would you try and figure it out?
Combine those
A little louder. We couldn't hear you, and you're in the front row.
Would it be negative 10?
It won't be negative 10.
it becomes
Because, and this is where I would still use our rules. What do we do with this one?
move it to the top.
We move it to the top.
And then they can move down.
And if you want to move this one, it's going to go to the bottom.
Okay.
So then it becomes
So what do we end
positive.
up with? 10 to the,
10.
because remember these are canceling.
Ah,
4.
So 10 to the 4th. Does that make sense?
Mm-hmm.
Because some are on the top and some are on the bottom. Now the rule, if you just wanted to go from here, the rule is you subtract. So -3 minus -7, if you want to use that rule, which also gives you 10 to the 4th. Okay, but if that rule is confusing, don't worry about it. I like to change them to positive, and then I can think of, oh, canceling and whatever.
It was a little confusing in the homework because I remember that I did that a few times in the practice one, and then they just gave me a total different answer. So
Yeah.
I kept getting it wrong until I flipped it.
Yeah.
And I don't know what I was doing wrong. I couldn't figure it out.
You figured it out eventually?
I was like, I'm just
Okay.
gonna do it this
That's
way.
why we have the practice. I really like to turn with positives. I don't like to mess with them with their negative because people forget the negatives, or either they ignore them or they just get messed up by them. So if we can make them so they're not negative anymore, that's a good thing, I think.
I think what I kept doing is leaving them on the bottom, without
Okay.
switching them
So
to.
if you had 2 zeros after the 3, is that what you do?
Well, if we were turning it to standard, yes, you're right.
Okay, what's the question when you turn it into that again?
It'll say write this in standard notation. Okay, so you're right. But what we want to do is write this in scientific notation. So where does our decimal point need to be?
After the 5.
After the 5, right? Because you see that this is too small. It's
Mhm.
smaller than 1. So we've got to put it there. So we're going to have, if we just deal with this part, we would have 5.3 times 10 to what power?
-1.
It's -1 because we moved it 1 space and it was a really small number. So that's that part. And then we have times 10 to the 4th. So what will our final answer be when we go ahead and combine these two tens?
5.3 times 10 to the 3rd.
Third power, add those -1 plus the 3, or plus the 4, I mean. 3.
When you move the decimal, right?
Mhm.
I was thinking if you went to the right, then it would be positive.
Mhm. And that's what I do not like, because sometimes people will make their kids memorize, if you move to the right, it's positive, you move to the
Yeah.
left, it's negative. But it depends on if you're going from standard form to scientific notation or scientific notation to standard form. And that's why I say don't think about that. Think about, is it a number that's a big number or is it a number that's a small number? Because we know the big numbers go with positive exponents, the small numbers go with negative exponents. So if you think about that ahead of time, then you're going to know if it's a positive or a negative. Okay, it's more of I like to approach it as a concept, because rather than trying to memorize, well, if I'm converting from scientific notation to standard form and it's a positive exponent, I'm going to move to the right 4 spaces or whatever. So think about big numbers have positive exponents, small numbers have negative exponents. So when we see this one, 0.53, it's a small number, smaller than 1. So it's going to have by itself, it's going to have a negative exponent.
So just try to know that if it's a smaller than 1, it's a negative. If it's bigger than 10, a positive.
A positive. And so then once we get this part taken care of, then we just combine these two with our normal exponent rules just to add them together.
Equal is minus.
Okay.
Yeah, that's my
I'm
number.
done. She walks in and she's like, oh, got it. Let me here for 2 hours.
You haven't been here for 2
Okay.
hours. But does that make
No,
sense
it
that the
does.
big numbers
It
are
does.
okay?
It's just the rules that I need to get.
Yeah, I wouldn't, again, I don't like to tell students to memorize right and left, because just think about big numbers and small numbers, because that simplifies it to
Yeah.
only 2 things. You only have to remember 2 rather than actually 4. So to me, the less I have to memorize, the better. Are we okay to go on? All right, well, good, we're done.
So, why we stop? Why you stop there?
Oh, why do we stop?
Mhm.
Because our goal was here, when we simplify it and it's in standard, our goal is to put it into standard, into scientific notation. So scientific notation, your first number is always between 1 and 10. And then you always have times 10 to some power.
What's the other thing called?
Standard notation. That's
Standard
just like
is
normal
like-
numbers.
It's 53.
Yeah, and you're exactly right on this one, Concha. This would be 5,300 because you'd move it over 3 spaces and you'd have 2 zeros there.
How do you say science?
Scientific.
Scientific.
Yep, because they use it a lot in science for all those really, really big things or those really, really tiny things.